Okay, let's just dive right into this explainer. We've got to ask a pretty fundamental question here. Is artificial intelligence some kind of alien mind destined to take over the world? Or is it literally just a really, really clever math trick built on top of human data? Today, we're going to look at the actual physical reality of AI. We'll explore how understanding the physical hardware completely shifts how we think about it philosophically and ultimately how we govern it legally. So let's get into it. We've got a fascinating micro to macro journey planned for you today. First, we'll start at the microscopic level with inside the NPU. Then, we'll break down the math of BFloat16. After that, we'll zoom out to view AI as a social collaboration, and finally, we'll unpack the concept of the legal phantom agent. All right, Section 1, inside the NPU. Let's see how the physical reality of the hardware totally dispels those sci-fi myths we're always hearing.
The brain of an AI system isn't really a brain at all. It relies heavily on a piece of hardware called an NPU, or Neural Processing Unit. Think about the CPU in your laptop for a second. It acts like a single, brilliant manager, focusing intensely on one complex task after another. But an NPU is built completely differently. It's designed specifically to process massive amounts of simple math, all at the exact same time. It's not a single genius solving a giant equation. It's much more like a massive choir of thousands of voices singing very simple notes simultaneously to create a booming harmony.
So NPUs are built purely for the dense, parallel math that actually makes up neural networks. To pull this off, they use what are called multiply-accumulate units. These are basically tiny engines, and their only job is to crunch massive grids of numbers, or matrices, over and over again. And here's a wild fact. In AI, physically moving data around a chip actually costs more power and time than doing the math itself. To solve this, an NPU brings the memory right next to the compute engines, squishing everything together to keep data movement to an absolute minimum and just maximize that efficiency. Moving right along to Section 2, the math of BFloat16. This is where we look at the specific, honestly kind of brilliant math trick that makes this hardware so ridiculously fast. For decades, standard high-precision computing relied on a 32-bit format. It used 8 bits to determine the massive size of a number, which is called the exponent, and a whopping 24 bits for the tiny, precise fractional details, called the mantissa. But AI researchers at Google Brain realized a secret. Neural networks don't actually need pinpoint fractional accuracy to learn. So they developed a brand new format called BFloat16. By shrinking the mantissa down from 24 bits to just 8 bits, they trade pinpoint accuracy for raw speed. Think of it like knowing exactly what city and neighborhood a house is in without needing to know the exact millimeter of the driveway. Now, the real secret sauce to BFloat16 is maintaining that 8-bit exponent. By keeping the exponent identical to the old 32-bit standard, the massive dynamic range of the numbers stays totally intact. This means the NPU can still calculate numbers as tiny as 10 to the negative 38th power or as unimaginably massive as 10 to the 38th power. That incredible cosmic range is exactly what deep learning needs to function, even if the individual numbers are just a little bit fuzzier. So why does this slight fuzziness actually matter in the real world? Well, because it yields massive computational throughput. By using BFloat16, systems get up to 4 times the floating point operations per second, and they literally have the memory bandwidth costs. This right here is the ultimate proof that AI isn't grounded in some sci-fi magic or digital alchemy. It's grounded in deeply pragmatic, highly optimized, and honestly rather blunt engineering. That brings us to Section 3, AI as social collaboration. Now that we really understand the physical reality of this low-precision math, it perfectly sets up tech philosopher Jaron Lanier's take on what AI truly is. Lanier makes this really forceful argument that we've got to stop viewing AI as a sentient alien. He points out that believing in the sentience of others, even other human beings, is fundamentally an act of faith. And pragmatically, we should place that faith in humanity, not in machines. Because under the hood, as we just saw, there is no alien mind. It is quite literally just our own human data, our art, our writing, our history, mashed together by the dumb math of BFloat16 running inside an NPU. And this leaves us with a pretty stark choice in how we frame this technology. Treating AI as an independent sci-fi creature just makes us feel paralyzed and obsolete, right? But if we treat it as a massive social collaboration, a new tool for mashing up human ideas, it gives us power and actionable paths forward. It means if a system produces biased or harmful outputs, we don't just shrug and blame a ghost in the machine. We look at the human collaborators who provided the training data, and we fix it right at the source. Okay, let's zoom out to our final macro layer, Section 4, the legal phantom agent. We're going to look at how the law actually manages the risks of this massive social collaboration. Since AI is, at its core, just a machine processing human data, the law doesn't actually need to invent whole new concepts or grant it actual personhood. As recent legal scholarship from Stanford Law School outlines, the law can treat AI as a phantom agent. This uses existing agency law to hold the human deployers responsible. The AI isn't a person, but it acts as a legally recognized phantom extension of the human principals who deployed it. It's a legal fiction designed perfectly to manage real-world risk. Think about it like this. When a firm delegates broad discretion to an AI, say telling a complex pricing algorithm to simply maximize profit without any oversight, they bear the risk of its unpredictable outputs. Just like a business owner is bound by the actions of a human employee who makes a bad deal, a company is legally bound by the contracts negotiated or the financial harms caused by its AI agent. And we're actually watching courts shift their perspective on this in real time. In the old inherited paradigm, AI was viewed as just a neutral informational tool, kind of like a calculator, where any harm was blamed entirely on the human end user. But in the emerging paradigm, courts are treating AI as an active, behavior-generating product. This shift is massive. It places liability for design defects and even foreseeable misuse squarely back on the human institutions that build and deploy these systems. But this brings up a really tricky area: the criminal responsibility gap. What happens when an AI causes harm, but no specific human directly intended for that harm to happen? Well, legal scholarship suggests a shift toward the standard of recklessness. When corporate deployers know an AI might predictably persist in a flawed goal and cause harm, they can't just throw their hands up and claim it was a mechanical accident. The law is beginning to view the deployment of opaque, autonomous systems into high-risk domains without proper safeguards as a gross deviation from reasonable care. I want to leave you with this final thought. When we strip away the science fiction, AI is just low-precision BFloat16 math running on specialized NPUs, mashing up our own collective human expressions. The phantom agent isn't a spooky, conscious ghost inside the machine. It is, quite simply, a mirror. So the next time an AI does something incredible or something terrible, ask yourself, are we looking at an alien intelligence, or are we just looking at our own legal, moral, and human responsibility reflected right back at us?